Hello everyone, in this video I wanted to share a new open source PCB project I've been working on. It's Nevermore Stealthmax PCB 2, electric boogaloo I guess. So this is a PCB designed for Nevermore Stealthmax air filters. It integrates a lot of different components that you need to source separately into a single PCB, like the buck converter here or these two MOSFETs. It has an STM32G0B1 MCU running Clipper, so it communicates with Clipper running on your Raspberry Pi using USB or CAN bus. It also has a bunch of connectors here, so it makes wiring much easier. And yeah, I'm pretty happy with how this turned out, and I will talk more about the features of this PCB in a sec. But since I never made a dedicated video about the original Nevermore Stealthmax PCB, so this is the V1, and this is still a PCB that you might want to use with Nevermore Stealthmaxes if you're printing the earlier version of the Stealthmax, or if you want to save some money, or if you're building a Nevermore Mini. This is still probably the best PCB you can use, but this has a bunch of new features that are ideal if you're building a Nevermore Stealthmax today, and if you want all the new features that are current and upcoming to the Nevermore Stealthmax filters. I also never made a dedicated video about the Nevermore Max 2 PCB. I did show this PCB in an earlier War on 2 video I made, but never made a dedicated video about this. So this was designed for my Nevermore Max 2 air filter that is currently on my War on 2.4. And since Nevermore Max 2 was sort of discontinued and morphed into the Nevermore Stealthmax, and since there was a lot of demand for it, I made the Nevermore Stealthmax PCB V1, and I released this sometime last year I think. But the Nevermore Stealthmax had some updates, and with the updates one of the things they changed was the location where the electronics mount in the Nevermore Stealthmax. And the new electronics location makes using this USB micro connector very difficult, like pretty much impossible, so you're stuck with CAN bus if you're using this with the newer version of the Nevermore Stealthmax. They also started adding a bunch of new features to the Nevermore Stealthmax, like UV LEDs through the photocatalytic add-on, and some upcoming stuff as well. Plus, some people weren't too happy with having to run 12 volts and 5 volts to this PCB, and they just wanted the buck converters built in. So this has 5 volt and 12 volt buck converters built in, so you just connect this to 24 volt power through this XT32+2 connector. So I ended up working on this newer version of the Stealthmax PCB. So let's talk more about all three PCBs in this video, because they're all still relevant depending on what filter you're building. So let's start with the older two PCBs, the Nevermore Max 2 PCB and the Nevermore Stealthmax PCB V1, and I'll talk more about the exact features of the new PCB in a second. So these two PCBs are pretty much identical, other than a couple of feature differences here and there, and their size and shape obviously. So depending on which filter you were building at the time, you'd pick one or the other. The project started with the Nevermore Max 2 PCB, since when I started working on this project, Nevermore Stealthmax didn't even exist. So this had an STM32G0B1 MCU running Clipper and communicated with Clipper using USB. This didn't have CAN bus. It had two I2C sensor connectors. These are JST-XH connectors. So you just wire a pair of sensors here and a pair of sensors here. And the STM32G0B1 MCU here would read those, and you'd see those displayed on your dashboard, whatever you're using. I guess most people are using Mainsail. This also had the 4-pin fan connector here, so this is 4-pin PWM fan. This had a 3-pin fan connector here as well, which this doesn't have. I'll talk about that in a sec. But the Nevermore Max, the original Max, not the Max 2, had a negative pressure fan, and there were plans for integrating that into Nevermore Max 2 as well, and because of that this had the 3-pin fan connector here, but they eventually decided not to do that, which is why this doesn't have the 3-pin fan connector. But this is a 3-pin, which means it also reads the RPM data from the fan, so this controls the fan like any other 3D printer controller would, but it also reads the RPM, which is an extra feature of this. This obviously reads the RPM as well, but it also sends a PWM signal to a PWM capable fan, which is the way you should control PWM fans. This also had a NeoPixel LED connector here, and this let you control the NeoPixel LED ring, which was on the fan hub of the Nevermore Max 2 air filter. The 5 volt for this and the rest of the electronics came from the USB connector here, and there was a fan power connector here, which provided separate voltage lines for this fan and this fan. So yeah, this was something I created for my Nevermore Max 2 air filter, and I'm still using this PCB. This is actually the exact PCB I'm using on my Nevermore Max 2 air filter. I just removed it to shoot this video because I don't have any more of these left. I sold out of these, and since the Nevermore Max 2 air filter is sort of discontinued. I'm not restocking these, which means this is the only PCB I have excluding prototypes. But anyway, that eventually morphed into the Nevermore Stealthmax PCB due to demand. So yeah, this is still pretty relevant, and you'd still want to use this if you're building the old version of Nevermore Stealthmax with the electronics mounted in the fan hub, or if you're building a Nevermore Mini, which this is perfect for in my opinion, and I will start a Nevermore Mini build pretty soon, and I will be using this PCB in that. But yeah, this also had the same STM32G0B1 MCU, 2 sensor connectors, the NeoPixel connector here, and the 4-pin PWM fan connector here. This also added CAN bus communication, because with the Nevermore Stealthmax, the earlier version of the Nevermore Stealthmax, the mounting location of this meant that routing a USB cable was really difficult, and you know, it also used the USB micro connector here instead of USB-C. I don't like USB micro Bs, but in this case I had to use this due to height limits in the electronics chamber of the Nevermore Stealthmax, so I had to use a micro here. But yeah, routing that USB cable was really difficult, so I also added CAN bus communication. And yeah, the power for the fan and the 5V for the rest of the PCB was connected here through this 3-pin connector, and all the connectors on this are JST-PH. Max 2 PCB use JST XHs, but again, due to height limits and space limits on the PCB, I switched to JST PHs with this one. Another feature of the Stealthmax PCB V1 is the on PCB sensor option. So this is an extra PCB that you can solder on there, or you can buy them pre-soldered as well. And yeah, the point of that is also to make wiring much easier. Since this was mounted in the fan hub of the Nevermore Stealthmax filter, which is where you'd want to have one set of sensors, you might as well have the whole thing built into the same PCB. So I added that as an option, and this sensor add-on and one of these connectors is wired together, so you use one or the other, and the other sensor pair you'd run wires to. And yeah, this was pretty popular. I know there are quite a few people using these out there, and yeah, I was really happy with the result. But there were some changes to the Nevermore Stealthmax filters, and one of the changes is, as I said, where this PCB mounting location was relocated to. In the new location, as I said earlier in the video, using this USB micro B connector is pretty much impossible, and this on PCB sensor option is useless in the new PCB mounting location because it's not in the path of the airflow, so you have to run wires to separate sensors no matter what, and this option is useless in that location. But it is pretty useful in the Nevermore Mini, because where the PCB mounts in the Nevermore Mini is just like the earlier version of the Nevermore Stealthmax. It's in the path of the airflow. So yeah, this is again a really good PCB for Nevermore Minis, and I will show this in action in a Nevermore Mini once I start building it, so stay tuned for that. But yeah, because of the changes to Nevermore Stealthmax filters, where this PCB is mounted, and the new features that are currently added and upcoming, and because of demand for the buck converters here, because people didn't want to ground 12 volts to the PCB, I ended up designing the Nevermore Stealthmax PCB 2, and yeah, this is, you can see a lot more is going on this PCB, so this has a ton more features. So let's talk about the features of the Nevermore Stealthmax PCB 2. Just like the Nevermore Stealthmax PCB 1 and the Nevermore Max 2 PCB, this has an STM32G0B1 MCU running Clipper, and it's using the same pins for its connectors that are shared between the PCBs as well, so you can probably get away with using the same config. And if you had an earlier version of the Nevermore Stealthmax PCB, even the pinouts for the connectors are the same, so they are as compatible with each other as possible. So with this one, you have 2 sensor connectors here and here for your intake and exhaust pairs of sensors, a BME280 and an STB40 each, and for those you can also use my PCB if you prefer, or you can use the Chinese ones. This also has the same 4-pin fan connector here, so it has PWM fan control, and it monitors the RPM of the fan. It's opto-coupled as well, just for extra layer of protection, and yeah, that's connected here. This doesn't have the NeoPixel LED compatibility that this PCB had, but it's not used in Nevermore Stealthmaxes anyway, and I had to take that out to add a bunch of new features to this PCB. So let's start with the UV LED stuff. With the Nevermore Stealthmax, you have an option of adding a photocatalytic add-on for extra layer of filtering. It does some filtering magic with UV LEDs. I'm not going to pretend to be an expert in that field, but yeah, photocatalytic add-on is an option, or down the line I know they're trying to implement the UV LEDs inside the fan hub, which is probably the reason for the relocation of the electronics. So yeah, eventually I think there will be UV LEDs that are inside the fan hub of the Nevermore Stealthmax filter, and you can control these through this UV LED connector here. This has a 12 volt power and ground, which is connected to this MOSFET, so it can be used to turn on or off or dim the UV LEDs inside either the photocatalytic add-on or the fan hub. There's also a thermistor connector here. That's for checking the temperature of the UV LEDs, and the Nevermore UV LED thing, when it gets released, will have a thermistor built into that PCB, so you can connect that here. This also has a thermistor on the PCB as well, right here, and that's for monitoring the temperature of the PCB, just in case you want to do that. You can also read the temperature of the MCU as well in Clipper, so you can actually have two temperature sensors from the PCB itself and connect a thermistor. So you'll end up seeing 3 different temperature readings in your dashboard, mainsail or whatever you're using, if you use all 3 sensors from this PCB. There's also an auxiliary connector here. This provides 5 volt power, also has a ground pin obviously, and has a 3rd pin that's going to the MCU through a logic level shifter, and that can be used to send a PWM signal or some other signal, or whatever you want to connect or control to this connector. It's also supported here. Some LED stuff, for example, require a PWM signal and power separately, just like some PWM fans do, because they have the control logic built in. You can control those through here, or yeah, you can do pretty much whatever you want with it. There's also a Peltier connector here. This is a microfit connector that has 24 volts and ground is obviously on this MOSFET, so you can use this to control a Peltier. That's not implemented in the Nevermore Stealthmax filters yet, but I know they're considering implementing Peltiers in Nevermore Stealthmax filters down the line. And the point of that is to cool the active carbon inside the Nevermore Stealthmax filter, and that helps increase the filtration efficiency, I guess, of the carbon without having to use Nevermore Scorch or not using it as much, I guess. So yeah, this will help with the filtration as well once they implement it into Nevermore Stealthmax filters. This also has 2 buck converters built in. So you have a big buck converter here that's for 12 volts, and you have a smaller one here for 5 volts. So instead of having to supply 5 volts and 12 volts to the PCB directly, you connect 24 volt power through this XT32+2 connector here, and the 12 volts for the fan and UV is regulated on the PCB, and the rest of the logic needs either 5 volts or 3.3 volts, and that's also regulated on the PCB. So the 5 volt buck converter drops that down to 5 volts, and there's a 3.3 volt LDO here for most of the logic. This obviously had the 3.3 volt LDO as well, but yeah, it didn't have the 5 volt buck converter, which meant that you had to supply 5 volt power separately or use USB, which does provide 5 volt power. With this one you can also use the USB connector for the 5 volt power. So if you connect the USB cable here, the 5 volt buck converter on the PCB will be turned off, and the 5 volt that's needed for the logic of the PCB will be drawn through the USB connector. That also helps make flashing this PCB much easier, because that means you don't have to have 24 volt power connected to run the logic of this PCB, meaning you can just connect the USB cable, flash your firmware, and then do your wiring, and yeah, it just makes it a bit easier is the point. But for the intended application of this, you probably want to use CAN bus, and yeah, you can connect that through this XT32+2 connector, and there's a TI CAN transceiver here. Yeah, that's the intended application of this. This also has the CAN bus jumper here. So the earlier Nevermore Stealthmax PCB, because of space constraints, I didn't have a CAN jumper on here, so I had this pad here that was pre-jumped. You could cut that trace in between, which would get rid of the 120 ohm resistor between the CAN lines, so it wouldn't be terminated. But that was the only way you could unterminate this PCB, and then you could jump these pads together if you want to re-terminate the CAN bus. But with this one you just have a jumper here. It is a tiny jumper, but I couldn't use the full-sized jumpers here because of the space constraints. So again, in the new Nevermore electronics location, the height that's available for the PCB is very limited. That's the reason I used the XT32+2 connector here. I would have preferred to use a microfit 2x2 connector, but that was too tall and it didn't fit in the new Nevermore Stealthmax Electronics location. So that's the reason I went with the XT30 2+2 connector here, and that's the reason for the smaller jumper. But for vast majority of applications, you'll just put the jumper thing on there and forget about it. So yeah, it's not like the Big 3 Tech EBB SP2209/2240 PCB where you're dealing with tiny connectors. The connectors on here are all JST-PH, which are easy enough to crimp. So that's the new Stealthmax PCB. As for how you're going to mount the PCB, this is the electronics chamber of a Nevermore Stealthmax filter. I don't have a Nevermore Stealthmax filter myself, but I printed the electronics chamber of it. And this is the electronics chamber of a Nevermore Stealthmax S filter, the 250mm version. But yeah, behind this cover here you can find the PCB, and this cover, if you want my logo on here instead of the Raspberry Pi logo, it's available on the GitHub repository of the project. But yeah, behind this cover here you'll find the Nevermore Stealthmax PCB mounted here, and you can see that there's plenty of clearance for the wires to exit, and on this side as well. And there is a custom spacer in here for mounting this, and the file for that is also available on the GitHub repository. And you also need these 2 screws to mount it instead of the 4 you need with a Raspberry Pi Pico. So if you remove this PCB from here, this is the custom spacer, and yeah, it means that this PCB doesn't wobble in place when you mount it, and it also spaces it enough to add enough clearance for this heatsink, which helps with the keeping the buck converter cool. Though even without the heatsink, it really shouldn't overheat. But being cautious never hurts, so I am supplying an extra heatsink with each Nevermore Stealthmax PCB 2 I'm selling, and I'll link the heatsinks in the GitHub repository of this project if you're sourcing your Nevermore Stealthmax PCB 2 elsewhere. As I said, it fits in the Nevermore Stealthmax S electronics chamber as well. So if you remove the cover, you can see the mounting thing is pretty much the same. I accidentally broke the standoff here while I was testing different mounting solutions, but the current mounting solution works just fine. This is from earlier testing. But yeah, it's the same spacer that you'd use in here. So if I remove that, you place the spacer on here like so, just align the holes, and once they're aligned and pressed in place, it's actually not going to move. It's by design as well. It's the gaps here, the gap between the wall here and the wall here is slightly narrower than the distance between the edges of these 2 standoffs, which means once you push this in place, it's not going to fall. So you just place the spacer and then put the PCB on top, align the screw holes, and then screw it in place. And even in the Stealthmax S, which is the smaller version, the 250mm version, as you can see, there's plenty of room for wiring on both sides. You might not be able to get away with a bulky XT30 2+2 connector or a bulky USB-C connector in the Nevermore Stealthmax S, but you should be able to use whatever you want in a Nevermore Stealthmax non-S, the 300mm version. But yeah, even in a Stealthmax S, as long as you use compact cables, which I am supplying an XT30 2+2 connector and pins with each Nevermore Stealthmax PCB 2 I sell, you can make your own cable is the point. You should be able to fit it in there just fine. So those are the mounts for this. The Nevermore Stealthmax PCB V1 fits in here just fine too. You obviously use all 4 screws for this instead of 2 screws, but as I said, the height in here is very limited, and while you have enough clearance for the JST-PH connectors barely, as I said, you don't have enough clearance for the USB micro B, which is the problem with the new Nevermore Stealthmax electronics mounting location, which is what led to me designing this new custom PCB for Nevermore Stealthmax filters. And while doing that, I also wanted to add a bunch of new features. So first of all, I posted a poll on the Nevermore Discord server in my vendor channel on Nevermore Discord server. Here, this was before Discord implemented the poll feature, I think. So this was posted as the old school poll with the reactions. But yeah, you can see that the most requested feature here, the option that got the highest vote was 2. It got 9 votes. I guess that's technically 8 because one of them is me. And 2 is 24 volt power input, no need to run 12 volt and 5 volt wires, meaning the 2 buck converters. This did have a significant impact of the BOM cost of the PCB. The current BOM cost of the PCB is 3 times what the original Nevermore Stealthmax PCB costed, and as a result the price I'm selling these at increased as well, though not as much as 3x, but it did increase. But yeah, that was the most requested feature. Another feature that was highly requested, got 7 votes, was CAN bus, which I was considering removing at this point, but yeah, because people wanted it, I didn't remove it, and I implemented that into the XT32+2 connector. And I also posted a few other options, and a few other options here also got votes. For example, the photocatalytic add-on got 5 votes, so the UV LED stuff was implemented. The UV LED fan for the photocatalytic add-on was not implemented. That's because the UV LED implementation in the Stealthmax is going to change down the line, but the UV LEDs will obviously be there, so the UV LED control was implemented. And the Peltier was implemented as well, because there is a possibility of Peltiers being used to cool the active carbon to increase the active carbon's filtering efficiency, as I mentioned earlier in the video. So those two were talked about on my vendor channel on the Nevermore Discord. And yeah, most of that happened back in March, but this was a really one of those Murphy cases where everything that could go wrong did go wrong. So I ended up having to order 3 prototypes, and I also had to buy a new testing tool for testing this project as well. And in the end, this project cost me quite a bit of time and over $1,200 to develop, but in the end it's ready and it's published on the GitHub repository now, and it is licensed under a GPL v3 license as usual. So on the GitHub repository you can find a comparison of these 3 PCBs, the 2 of the older ones and the new one. You can find the instructions, which I did spend quite a bit of time trying to improve these, because I know my Nevermore Stealthmax PCB instructions were a bit less than ideal. Instructions are really difficult to do well, but I really tried to improve these as much as I could. But yeah, there are things that are a bit complicated with configuring 3D printers and PCBs and stuff like that, as you know. But yeah, I tried to make this as clear, as understandable, and as simple to follow as possible. And yeah, you can find the instructions on the GitHub repository, which is linked in the description below, and I made sure to update the instructions for all 3 PCBs. You can also find purchase links for these PCBs in the GitHub repository, which is again linked in the description below. What you're seeing on the screen right now is not quite up to date. I will update this later. But yeah, there are more vendors selling the Mini Stealthmax PCB, for example, than what you're currently seeing. Nevermore Stealthmax PCB 2 is new, which is why I believe I'm the only one selling it right now. But it is GPL v3 open source, meaning vendors are allowed to sell it and they don't even have to pay me a cent. So yeah, I'm sure there will be more vendors, and once there is, I will update that as well. But yeah, speaking of other vendors being able to sell this, you can find the source of this project. I use EasyEDA to design my PCB, so you can find that source here. You can find the Gerbers, BOM, pick and place files, etc. So you can order these PCBs from your favorite PCB manufacturer, like PCBWay for example, by providing them with those files as well. So yeah, all of that is in the GitHub repository, which is linked in the description below. Also down there you'll find some links to support the development of open source projects like this, like my GitHub sponsors page and my Patreon. So GitHub sponsors is pretty cool because they don't charge me any fees. You can do a monthly or one-time donation on there, or on my Patreon. You can find a bunch of exclusive and early access posts, like updates on my PCB projects and stuff like that, and the occasional behind the scenes video as well. It's a great way to support the open source projects that I work on and the channel. So yeah, they are all linked in the description below. And as I said, there will be a Nevermore Mini build coming to the channel pretty soon. As you can see, I already started shooting it. It's not done yet. I haven't started editing it at all, and I still need to do the software stuff for this. But this is a filter that's going to be going into a new 3D printer build that I will be starting later on the channel. So there will be a new 3D printer build coming to the channel pretty soon as well. And there are 2 more videos that are coming to the channel very soon and soon-ish. There's a video about the filamentalist spool rewinder for Enraged Rabbit project carrot feeders. This is already edited, so it will be released pretty soon. And I'm also working on the next episode of the Voron 2.4 Doom Cube, which will be mostly about the Enraged Rabbit project carrot feeder. So I know I haven't released many videos lately, but there is always something going on behind the scenes, and yeah, definitely stay tuned for these. I'm just trying to release these videos when they're done, instead of rushing videos on a schedule, because I want to make the best video that I can make, within reason, that is, of course. So yeah, definitely stay tuned for these projects as well. But that's it for this video. I hope you found this project interesting. If you did, please leave a like down below, and thanks for watching.